turns out about 1.1.4. Like the one thing that stands out here is being able to always remember that all exponential laws are exactly the same as all surd laws, you see. So what I mean by that is, if you saw the previous question, the way we like worked with the square root symbol, we turned the square root symbol into an exponent. The reason for doing that is we were just trying to highlight that anytime you change a square root into an exponent, it becomes more easier to work with. You become more open to various possibilities. Just like this question, if you look at the way it looks, right? If you look at the way it looks, the square root symbols here is what is the one thing that may throw people off, you see. But the easiest way to not get thrown off by square root symbols is to just change them to fractions. Not all of them, but then the ones that may seem to be causing the biggest problems, of which, I mean, like the bigger they are, the more likely you are to change them into exponents, you see. What I mean is actually very literal. Like, look at this square root symbol, it's just so long. So you're better off changing it into an exponent. So here you're gonna end up with like square root of 32, right? Plus x. But in this whole thing here, you are better off maybe putting it to the power of a half. And then this whole thing is being multiplied by square root of 32 with a minus x here. And then that whole thing, you're better off putting it also to the power of a half. You see that we haven't done anything yet.
Yeah, I see it.
Yeah. But the reason for us doing what we have done here is we want to easily see what we can do when we have like square roots and stuff. What I'm just trying to emphasize here is square roots work the same as exponents. So here you can already see there's something to the power of this exponent and something to the power of the same exponent. So this should remind you of this exponential law, that if two things are to the power of the same exponent, you can just put them both under the same exponent like this. You see, this is familiar, right?
Yeah, it is. It is.
Yeah. So it goes back to at least knowing your exponential laws. If you know exponential laws, you better be able to like recognize what's written on the memo. So on the memo, you may have seen that this, they may have easily just written it as this bracket and this bracket all under one long square root symbol. They can do that because it's the same as what we're doing here. These two brackets here, square root of 32 plus x, square root of 32 minus x, the whole thing is going to be to the power of a half. You see? Do you see that?
Yeah, I see it. It's just so messy.
Yeah. So in terms of it not being messy, it's a matter of being able to go from something that's small to something that's big, because something that's small here is just this placeholder and this placeholder. Just like how this thing here is more like a placeholder. It's in the place where A would be. And then this whole thing here is in the place where B would be.
No, I see that.
Yeah. So in terms of these kinds of questions, right? This kind of way of seeing things is something that should maybe help you understand the memo better. Because if at first glance, maybe you may not think this way, when you will see it on the memo now, you should then be able to recognize, oh wait, they just used this law. Oh wait, they just used this law. So that here, you can work more on the inside here. Even if you don't want to work on the inside here yet, what you have the ability to do here is, I mean, like one way or the other, anything to the power of a half is as good as a square root. So what you could do is, remember, whenever we need to get rid of the square root, we like square both sides. So here you could actually just square this side and also square that side, meaning you're going to have these two brackets on their own, and then this side equal to x squared. Do you see it?
Yes, but Oh, okay, never mind. Okay. I got it. I answered my own question.
Yeah.
Thanks.
Yeah, because fortunately a half times 2 is just a 1. So this whole thing here is
Yeah.
technically to the power of 1. You see, of which we
That's
don't
what
need to
made me
write.
stutter, but I got it.
Perfect. And then here now we can just distribute what you call our, we can just FOIL. This is likely the difference of two squares, because remember, this is something plus something, and then the exact same thing with the minus. So, but anyways, without overthinking it, let's just go. This times that,
Okay.
gonna give you a 32 in the calculator. This times this is gonna give you negative x square root of 32. And then here, this times this is gonna give you positive x square root of 32. And then x times negative x squared. And then this is gonna cancel that because those are like terms. And then here we're left with 32 minus x squared equal to x squared. And then we can put everything with x on one side. We're gonna have 32 equal to x to the power 4. And then we can just put a surd symbol on the, wait, what am I, whoa. This is so off. Let me remove all that. Goodness, what is that? So on the right, we're gonna have here a square, a surd with a 4 here. And then we do the same over here. And then here it's just our calculator that has to do all the work, of which our calculator here, I think it's going to give us a 2. Because 2 times 2 is 4 times 2 is 8 times. What? I don't know. No, I don't think it's 2. What's the answer here? Because I think with 2 it's like a 5 or something. Or 16. No, I am lying. No, man. It's 1. I don't know. What's the answer? I don't have my calculator.
Yeah, my calculator. It's giving me 2,38.
What's the third version? What's the answer without the decimals?
Oh,
Or like,
it's not actually giving me that. Let me just.
it's only giving you decimals.
Yeah, not giving me anything else, just the decimals.
Interesting. You said it's 2 comma
38.
2,38. Well, let's see what the question was here. They're asking us to solve for x. Okay, so the easiest way to test our answer is you can just put in the answer here and the answer there and see if this left side will be good to the right. Let me actually grab my calculator also. I'm not be lazy. Where's this calculator that I'm always losing? Let me just grab this calculator and then we can put our answer in the calculator. And then we can see what answer we got. I don't know where my, there it is. I found my calculator, So let's see. Before even carrying on though, I must just double check if, yeah, it doesn't look like there are any errors here. So wait, no, dude. There's a big error right here, bruh. I mean, cause look, this one,
Oh, you with the hair.
yeah, because these are like terms, so it's gonna be x squared plus x squared. Yeah. I don't know how that error slipped in, but I'm glad it slipped in because I think at least now we can all be on the same page when it comes to mistakes. Mistakes are just not something to avoid, but something to always double check. So in terms of us double checking, I mean, the mistake presented itself as it always should. And in terms of checking, it should just be something routine. It should not be like, oh my God, it's wrong. Oh, snap, I'm an idiot. No, there's no point in doing that, because I think that's just
An exam.
yeah, it takes too much energy. So this is just 2x squared equal to 32. Divide both sides by 2. And then this is x squared, 16. And then we can square root the right. And then we can square root. What is going on here? What is going on? Square root the right, square root the left, x is a 4. So I think with what we have just done here, yeah, it's just an indicator that Oh, well, obviously, I mean, like decimals are mini red flags. I mean, like, I'm not saying they're always wrong, but it's a good indicator that it's time to check if everything was done correctly. You know, that's what you may call decimals are good for. They're good for giving you hints
As
because,
a red flag.
yeah, definitely. So you take the red flag, ne? And then after taking the red flag, you just double check your workings, you know. And then the moment you find the error, it should be like a moment of, you know, of happiness, not grief and depression. No, no, no. It should be like the best thing ever because it's like away, you know. That's how it's supposed to be.
I'm trying to think of it so positively.
Yeah, I mean, that's all we